Activity is the rate at which nuclear decay occurs in a sample containing unstable nuclei. So here we have a set of unstable nuclei. The white circles with X's are the nuclei that have decayed. So say we have 5 decays that have happened over the space of 2 seconds. This describes the activity. Remember that nuclear decay is random. The decays aren't spread out evenly over this time, and the activity can change slightly within each 2-second period. Therefore, it's best to measure activity over long time periods or for large numbers of decays. That way there's less variation due to the random nature of the decays. So what units do we give activity in? Activity is measured in becquerels, or BQ, where 1 becquerel is the activity of a radioactive sample where 1 decay occurs per second. So using our sample, we can get the activity by dividing the number of decays by the time, and that gives us an activity of 2.5 becquerels. The activity of the sample depends on the isotope and also the sample size. So how exactly can we measure this activity? Well, radioactivity can be detected using a Geiger Müller tube. This is sometimes abbreviated to GM tube. A Geiger Müller tube has a clicker dial on the front and a tube which can be directed at the radioactive source. Some common examples of radioactive sources include radium gas, uranium and plutonium. And we can detect radiation by pointing the tube at the source as the radiation spreads out in all directions from the source. When taking measurements like this one, it's really important to keep a safe distance, to wear protective clothing like gloves, and also to store the source as soon as a measurement is complete. The Geiger Müller tube clicks when the radiation has been detected. But how does this tell us the activity? Well, the count rate is the number of nuclear decays the Geiger Müller tube detects every second. So for example, if the tube clicks 3 times in 2 seconds, we can work out the count rate by dividing 3 counts by 2 seconds to give us a count rate of 1.5 counts per second. And longer periods of counting can lead to more accurate count rates. So is the count rate the same as the activity? Well, the count rate will be less than the actual activity of the source. And this is because the Geiger Müller tube only detects some of the radiation from the source. So the radioactive source emits radiation in every direction, but we're only measuring a small amount of the radiation emitted in one direction. So the count rate is less than the activity. You should know that count rate helps us calculate the activity, but you don't need to know exactly how for your exams. Something else to consider is that some counts could come from background radiation, so this is something to check.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!